Morning. Well, that's probably a little seizure inducing. Howdy. All right. How are we all doing today? Morning. Soft slide. Yeah. Boop. Stop. No, go away. All right. Let's get going here. Okay, I am so confused. Not, so I did some recording for one of my other classes over the weekend, and completely different interface for presenting. Um, Today, this one's back. Something funny is afoot at Google Slides HQ. Anyway, not really a big deal. But I was looking for notes. There we go. So, hope you all had a good weekend. I will make the next assignment available after we get a little bit farther. It's going to ask you about some stuff that we're probably not going to touch on until Wednesday, so I don't want to necessarily open it up and you're gonna have no idea what the heck the homework's about. But if you want to get started thinking about it, your um, a big part of it's going to be a group assignment where you basically list out all the tasks that you have remaining to do for your term projects. You're going to try to figure out who will be working on them. So it doesn't just have to be one person, but we should be able to figure out who's doing what and set it up in either a Gantt chart or a burn up or burn down chart. I've got some links at the end of the next set of slides, which I need to remember to put up because I don't think I've made them available to you. But basically how to create any of these charts in like Excel or Google Sheets or something like that. So we'll get to that point. But that's going to be kind of the thing. I've got some homeworky type questions for you on the content so you keep up, and then I've got some actual work for you. And yeah, that's going to be about it. So only other thing to really talk about before we get into the material, I don't know what Friday is going to be like for class yet, so I am planning well, I'm not planning. I'm getting my second round of the vaccine on Wednesday, and I'm assuming based on how badly I reacted to the first one that I'm gonna get probably wrecked by the second one. So we are either gonna do something lightweight or probably something in class or something. I'm not sure what it's going to be yet, but Friday I'm going to guess will probably be a different format than the Twitch stream. Initial guess. I'm not sure what it's going to be like. I'll probably know Thursday, but we'll send out an announcement for that. Okay. Otherwise, we can get going with part two of this. And there are going to be three parts to project management and planning, and then we'll get on to design patterns and fun stuff like that. This one's a little bit interesting because we're going to be talking about actually figuring out effort and managing risk. And these are going to be two concepts that you are going to have to deal with as project managers when you, again, start specing out projects. That's kind of what this whole module is all about, right? Figuring out what you need and what you have to do. And uh, as you can see by this nice little GIF I've inserted, it's a balancing act. Um, you're going to have a lot of things to deal with. So, if you're following along in the book that I didn't tell you to buy, we're in chapter 3, but we're basically going to be figuring out effort, which is a thing that you're going to tie in with your projects to figure out what you need, what kind of people you need, how long things are going to take, costs, all of this fun stuff that we have to deal with. All right, so first step, let's estimate the cost of a project. This is one of the most crucial things that you will do as a manager. We're figuring out budgets, we're figuring out costs of our employees, we're figuring out licensing fees. Basically, there's going to be a lot of effort going into planning and costs. And let's pop some of these all out there, the animations. The goal is to get it done as early as possible. And the reason why is that most companies, whether you're a startup, whether you're a massive company, whether you're a nonprofit, it doesn't matter. You should know early what you are going to have to pay for a project to be successful and who you're going to have to hire to make that happen. Now, what do we have cost-wise? Obviously, we have people, right? So we're going to need to pay our employees, our staff, administrative support, facilities support, which is going to be the people managing the building, managing your space. There's costs with that too. I'm reading these in reverse order. We're going to need the tools to build our software. So if you're paying licensing fees, I know a lot of you are going the video game route. So let's say that you become an overnight success, which would be awesome. But then you start selling game units and hey, Unity comes along asking for their fee because you are now a, $500,000 um, type of company or not. You're selling 500,000 worth of units. I don't know what the threshold is for Unity these days for a cut, but yeah, you have to start paying for things. And then, yeah, the facilities, this is going to be maybe the hardware that you have to buy, the space that you have to rent in an office building or in a warehouse. All those cubicle walls and desks and chairs, you're probably renting or buying. It kind of depends on your environment. Telephony, so video, voice, straight up normal phones, IT infrastructure, all of that has a cost. And this cost tends to be shared among projects. Again, depending on your company layout, you might have a line item in your budget saying rental for office building or your space that you're housing your project team. But with this, and I should warn you, I've got a few slide-dos in here for interaction, so I will wait patiently for answers as we go. Anybody have an idea why people cost so much? So let's say that we are specing out our project and we've gotten to the line item where we are budgeting out money for our employees. They're going to be a pretty massive cost to your project. And any idea why they cost so much to support and maintain? Any guesses? People are a hot commodity. That's true. Hey, you get a good set of employees, then they are definitely a hot commodity. It is their job. They need to support and maintain their life. Absolutely. So we're paying them a salary, right? Regardless of where you get hired in at, you get X dollars per year, after tax. You're not just paying that though for people. You're also paying health insurance. You're paying all the extra fees that go in with it. You might have union fees depending on your situation. Um, Various types of insurance, not just health insurance, life insurance, accidental death and dismemberment insurance. Basically, there's a whole lot of extra things that go with employees, right? Not just your salary. Specialists in overtime. Yeah, that's a good point too. So maybe you are bringing in somebody who is going to help move your project along, and you're paying them consultant fees. Or you have to pay people overtime because you've gotten into crunch because you didn't plan appropriately. Yeah, so these are all good. Yes, taxes too. Absolutely. The point is that if you go into this kind of naively, not realizing there's going to be all of these extra costs that go with people, you're going to blow out your budget pretty quickly, and then you're going to wonder how you got into this situation. So yes, all good points. Now, when we're doing this effort estimation process, you should really be doing it repeatedly and kind of refining things as you go and as you get more information. This is a pretty well-known figure, so this is called the cone of uncertainty. Basically, the way to read it is that, this is the x-axis are the kind of forward points in history, the milestones of our project. And the y-axis is going to be either size or cost. It just kind of depends on which metric you want to look at here. But basically, as you start out, there is a large amount of uncertainty in your values that you're picking, right? So if I estimate costs on day one, that may wildly change by the time you get 3 months into the project. You realize, hey, we need to hire a whole bunch of consultants to tell us what we need to do. We need to license all of this software. We need to bring in an extra project team from another location. We need to rent out space for them to work in, pay their hotels fees because they're staying here for a month. Um, all of that kind of fun stuff. Basically, as the project kind of coalesces, the uncertainty decreases, meaning we know what we need, we know what we're doing, and we know kind of where we need to go. So basically, the idea with uncertainty is that things are more uncertain with the less information you have. And that sounds like a very obvious point to make, but uncertainty is like an entire field of mathematics, and as is information, if you've kind of gotten to that point. Um, and the more details we have on our project, the more we know what we actually need to be doing. Saying that out loud that way, it sounds like, yeah, okay, sure, that makes sense. Um, but this is the same thing with our project development lifecycle, right? As we kind of move along in the process, we know the tasks we have to do, we know what we have to do to get to the next milestone. Same idea with project planning and budgeting. This SLOC acronym that I haven't talked about, this is software lines of code. So basically, it's the size of your code base. Um, just kind of reflects the cost in a way, basically. So if you refine as you go, don't just say our effort estimation is a one and done type of situation. It is going to be a continuously refined process. So part of your weekly or monthly tasks might be to check the budget or check the project plan and make sure that you're currently on track to hit your goals. So let's say we are at the feasibility and early designing planning steps of our project, and we start estimating out our budgets and we start estimating out the people we're going to need, and we're wildly wrong. So what do you think some reasons for these inaccurate estimates could be? So I keep floating this term uncertainty along, but what I'm looking more for here is what this actually means for a software project. I should really point out that cone of uncertainty is a generic figure. doesn't have to be a software project. It can really be any type of task where you are, planning something out and taking it through to completion. It could be a civil engineering project or a house that you're building. So, what are some of the things we have to deal with here, I suppose? Let's do this because I'm feeling cheeky today. COVID. Wow, that is a wildly appropriate guess there. Yes, there we go. Oh, you know what? Let's not do that. Let's do this one. It's really loud in my ears. Uh, there we go. Okay. Project that takes less time than was first imagined. Oh man. So while the answers are coming in here, the 10-hour YouTube videos were just becoming a thing when I was doing my grad studies. And that one and Darth Vader breathing for 10 hours, we would just leave on a machine in the lab and just let it go all day. It was great. And the best part is that at some point it just becomes kind of soothing background music, which is says something about us, I suppose. All right, project that takes less time than was first imagined. Right, so you over budgeted then in that case. That's actually a really interesting point, and it's something that does happen. We need 10 engineers and it only actually takes us two. Why are you so wildly out of scope? Absolutely. Customer adding functionality. Sure. Somebody piles on extra work and we didn't plan for that. If you are going the agile route, that is something that you probably should take in mind. Absolutely. They're taking the hobbits to Isengard. Yep, that can definitely be one reason. They just get stuck in a 10-hour loop. Scope changes, code doesn't work the way it's planned to be, corporate wants monetization. Ooh, we're going the DLC route. Unexpected event happens, COVID. All definitely great answers here. Um, Basically, things are not the way we anticipated them to be. Things have changed. And this could either be catastrophic to your project, right? Meaning that, well, we have to go and redo the whole thing now, or we do that refining process. If COVID happens again, let's say, and we are all of a sudden thrust into this remote working situation, companies that have invested in remote work weathered it a lot better, right? They kind of foresaw the need for people to work remotely. Let's leverage these tools and capabilities. Um, Companies that are not able to take advantage of remote work are getting hit a lot harder. And um, obviously, natural disasters are not really something you plan for in a typical engineering project, but being flexible is usually a good thing to build in. And trying to think of where else we could go without taking this to a dark route. But changes and uncertainty in what we are actually developing all can impact a project. Basically, it's kind of usually good to build in some flexibility into your budgets um, without going too overboard, really. All right, full screen, come back. There we go. So some other things that we have to deal with, and you have hit some of these. So let me pop all these up so you can see that. So frequent change requests, which you all got. It's possible that we overlooked some tasks as well, meaning we didn't do a great job with our initial feasibility studies or our initial designs. Um, so we just missed something, and then we realized, oh crap, we actually need security in our backend, or we're going to need cloud services because we're now expecting 500,000 users instead of just 10 people using this application. Um, Maybe we have insufficient effort prediction, right? So maybe we don't actually know what we're doing and we're trying to plan out a project. Possible that we have a lack of coordination in our team too. So keep in mind that your team is not just going to be software engineers. You are going to have people running your infrastructure, meaning like your IT staff. You're going to have people working with all your data. You're going to have operations, facilities people. There's going to be lots of different people with lots of different roles. And if they don't talk, if they don't communicate, if everybody's not on the same page, it's possible we're going to have delays as well. All right, so keep in mind that I'm going to pick on those of you doing games again. You are all in this class because you are more than likely computer scientists or, computer science adjacent, so cybersecurity or IS or something like that. But you're all technical people. Probably you all can program pretty decently. When you get into industry, you're not going to have that. Everybody's not going to be a programmer or a technical expert. You're going to get graphic design artists, you're going to get marketing people, you're going to get people from business, and you're going to get lots of different backgrounds. And if you are thrust together in like a video game project type of thing, there might be a few people working on the game engine, then you're gonna have to bring in artists and sound people and quality control people, and there's going to be all these different perspectives and backgrounds. And if you're not talking, if you're not all kind of working in lockstep, it's very quickly that you can kind of have extra delays because they don't know what you're doing and you don't know what they're doing. To kind of take this example to fruition here, you are the developer, you've put in a bunch of moving cubes with, we could use the Counter-Strike or Team Fortress example where everything is an orange box with like a little infographic stamped on it, and that's our boilerplate text. Or there's the Gary's mod, everything's like that hot pink kind of missing texture type stuff. Well, then the artists come in and they give you all the models they built, and they don't match up with the sizes of your placeholder um, elements. What's the correct word I'm looking for here? Not elements, resources. Is your collision detection now off? Is your um, polygon count off? Does your frame rate dips? Basically, there's a lot of things that can happen when you bring people of different backgrounds in. And being able to be on the same page and communication, going back to that last set of slides, is going to be key here. Maybe, maybe you just did a crap job at estimating because nobody has followed a particular method or guide for that. So you just kind of are throwing darts at a dartboard to figure out, okay, this is going to cost $10 million. We're going to need 500 people. What we're going to find out in the next set of slides, after this one, is that we actually have methods for estimating. We can use algorithms and past data, past experiences to kind of actually build up models of effort estimation. So keep in mind that is coming. Now, as we estimate what we have to be doing, we have to manage something called risk. And risk is, here's the definition right there. I was going to talk through it. Some days I'm just not in the mood for animated slides. Today's one of those days. If you're looking to slow down your presentations, it's a little presentation thing for you. Put in animations and understand where they are because you can go through a lot slower if you need to. But what is a risk? It is something that has a negative consequence to your project. And that something is kind of a nebulous idea. It could be anything. Natural disaster. Somebody quits. Your project license expires before the thing is done. Your user base hates the project that you have made, or hates the product that you've made. Basically, a risk is a thing that happens that you have to manage. Okay? So, what's going to be very useful for you when you are estimating things is trying to figure out what all the risks are before they happen, right? So, if we are sitting down, we're trying to estimate what we have to be doing for the project. Okay, well, let's go through. Here's the risks at each step of the way. What is one risk? Well, maybe our project teams don't gel, meaning that you all as teammates hate each other. Okay. And you can still work together if you hate each other, but it's probably going to be a lot rockier and you're not going to end up with something as cohesive as you would have liked. Or, maybe somebody gets sick, maybe the project tool set falls through. These are all things that we can kind of anticipate and try to manage. And what's going to be really helpful here is to try and figure out, and this is where we start getting a little bit line item-y. Let's try to account for everything in a spreadsheet type of a mindset. Okay, what is the risk? What is its impact on your project, and what's the probability it's going to happen? And these can be very, very generic. They can be very project specific. It just kind of depends on the risk itself. But how do you manage risk with teammates hating each other, right? I have said you all have to be in teams whether you like it or not, because that is the purpose of software engineering is to work together. Okay, well, maybe three or four of you have no idea who you are at the start of class because we're doing this on Twitch and Zoom, and your personalities don't mesh, which is fine. What can we do to fix that? Well, we can add on extra group work so you do a lot more talking. We can have you meet weekly so that, again, communication always stays open. Everybody knows what everybody else is doing. Maybe you do some trust falls or you do some kind of a team building activity where you all realize you're better off together than separate. Kind of your standard industry approach to working with teams. And with COVID, I'm not having you all fall into each other's arms because that'd be a little bit weird anyway. But managing this and figuring out what you have to deal with early on is kind of important. Okay, maybe the team-based example is not going to hurt your project. It'll be rocky and it's not going to be fun, but it will get done in the end. But what if you build it and it's not up to the specifications that you need? And let's keep this going in the example of our class. Let's say you all put all the time and effort in, and I end up hating it. You get an F. Just extrapolating it. So far, you're all doing great, by the way. That is a risk, right? You have built something not to specification. How do we manage that risk? Well, we get frequent touch points with grades, we get frequent feedback, and we can kind of see the path that we are taking. Whereas if I just tell you at the beginning of class you're doing a project and then we do not talk about it until the final exam, that's a very easy way for that risk to kind of explode in everybody's face. So that's kind of some of the things that we have to deal with here and extrapolate to industry, right? If the customer doesn't like our project, all this money that we have invested in this project is now gone. There is no payback for a company, there is no reward, basically. So, with these risks, we have a kind of generic figure here where we can kind of get an idea for how impactful a risk is going to be. And this is, again, a generic figure which may or may not hold depending on the risk, right? But if we have something that is very rare to occur and it's pretty negligible to our overall project, it's probably going to be a pretty low impact on us, right? So it's a pretty low priority thing that we have to manage. Example would be um, we're building a 3D simulation where we have a character walking through the forest. And based on a crazy series of events, I'm going to start walking backwards into a mountain, and then I fall through the mountain and I fall into the negative world space. All right, so our collision detection doesn't match up at the seams of this mountain with these particular weird angles. Um, I think that was either a Twilight Princess or Breath of the Wild bug, if I recall. But very rare that it happens unless you actually go looking for it. Is it worth the effort to fix if it's this one little negligible thing? Probably not, right? We have so many other things to deal with. Whereas if you have a catastrophic thing, right, let's go over to maybe an autonomous car where we have pretty basic machine learning pattern recognition algorithms running, and it can't distinguish the sky from the side of a semi truck, which would be an example from Tesla a couple years ago. That's a pretty catastrophic thing that can happen. You know, you crash into a truck and the car is just driving along thinking it's looking at the sky. If the right set of circumstances happen, you know, it is certain that this will occur. It's a catastrophic failure. It is an extreme risk that we have to manage, right? So you kind of see this as like a almost a gradient of concerns, really. How bad is this thing? Again, this thing is in quotes. If it happens, what is the risk, right? How bad is it? How often is it going to happen? Is it worth the time to fix before we put it out into production? And what you're going to find is that in the real world, you get out into industry, we're not going to fix everything before release, which basically means that you know you're putting out products with issues, which is why autonomous cars freak me out because I used to work in automotive and I know the design practices we used to have over there. But, you know, basically, there's no way that we can ever fix every single problem. You would never release anything. But managing your risk and figuring out what the worst things that can happen are and dealing with them ahead of schedule or ahead of them actually happening is very, very important. Right. So we now have some activities that we can be doing to actually reduce this risk. Key so far, let's try to figure out what we have ahead of us to deal with. Right, what are the possible risks? How can we actually manage it now? First things first, we can avoid the risk. So we can make it so that this risk never happens to our company. All right? Maybe we change our requirements. So if we have a product that we're putting out, and based on our requirements, we know there's going to be this particular risk that can happen, well, we can change our requirements so that this risk is not our concern. Right? Maybe instead of, let's go the autonomous vehicle example here, we're building an autonomous car. The risk is that our algorithms are not up to snuff and we cannot perfectly drive autonomously without a ton of help. Okay, well, let's change our requirements to make it semi-autonomous. So the driver has to be fully aware, the driver has to have his or her hands on the wheel, and be able to take over at a moment's notice, which is your um, poorly named autopilot currently. So, could be that we just spec out our project to not include that risk to us, which is fine. We don't want to get into that area. All right, second, let's transfer the risk. So if we're again building a system where some risk is probably going to happen, let's make it so that some other system takes that risk on. Or if it's not like life-threatening or anything like that, we can buy insurance to cover the cost of that risk. Right? So if we have a product defect that can happen at the manufacturing plant, maybe we take out insurance for any future lawsuits. So this is kind of your, if any of you have seen Fight Club, this is our the scene where he goes through ticking off the insurance payback reasons for airline crashes. Or you could transfer it to another system. So that's the other side too. Maybe your system is just not set up to handle it, but there's another component, there's another subsystem, there's another product that can handle this. Well, maybe we license it out, maybe we include it or incorporate it in some way, and then that system deals with the risk. Third, we assume the risk. So you accept it and you control it. And what that means is that if you have figured out this list of risks that you will have to deal with, well, own it and deal with it and deal with it appropriately. This is kind of the kind of the nice way to manage it really because you already know this is going to be a problem. It should be on you to deal with it. Don't just kind of push it off to somebody else because that's kind of disingenuous in a way. If you can, right? Maybe it doesn't make sense to take the risk on. This is a very, again, kind of like budgety, line item-y type of view of a project. So we have some costs with risk as well. So if you want to sit down and actually calculate out what a risk is, what is our exposure before we have to go through this process versus the exposure after, meaning how likely is this to happen before and after we have done something about it, divide that by the cost, and then you have a value for, how this risk is going to impact you. And these are kind of generic placeholder numbers, right? We're not going to actually fill this in with anything. But you could look at it maybe in terms of thousands to millions of dollars that we have to deal with for risk. Is it worth it to manage it? Is it worth it to build it into our system? Is it worth it to offload it to somebody else? Just kind of depends on your company's perspective and what you are technically capable of. Right. So we have this notion of risk now, not just the board game. What are some typical risks that we may have within a project? Why is my phone blowing up at 9:30 in the morning? So what do we have risk-wise? I could also do this one while we wait for answers to come in. So again, question is, what are some risks that we have to deal with? I've been just giving you generic ones. There we go. Perfect. Yep, I will take answers in the Twitch chat too. That works. Requirements are poorly defined. Yes. Great, great answer. Just leave this on for the rest of class. Oh, that'd be a little bit too distracting. So, in chat, requirements poorly defined miscommunication between engineer and clients. Bang on, absolutely. So we have a set of requirements that we have defined. Somebody doesn't understand them at some level, and expectations are not going to be met. Absolutely. Not implementing features correctly could go hand in hand with requirements being poorly defined too, right? If we are not, excuse me, if we are not clear in our requirements, then there's a good chance that somebody is not going to understand something. That's why I'm trying to really, hammer on you all for being very clear with your requirements so that there is no chance that anybody could misinterpret it from me to any of you on your project teams. Yep. Okay, other ones over here, going over budget, overestimating budget. Both good, absolutely relevant to what we've been talking about. Underestimating the time needed. Sure, that's where you get into crunch, that's where you get into overtime, and not necessarily ending in a good place. Agile could cause programmers to be unstructured and inefficient. True. Um, Hopefully my cynicism hasn't infected you all with Agile. I know there are a lot of project teams that use and love Agile. If Agile is managed appropriately, it is a great design pattern, great strategy for implementing software. But you also do see that too, right? So you do see that if it is not managed appropriately, you get programmers who can be inefficient, sure. Maybe wrong choice of module and bad project management. You can't be, yep, yep, yep. So with anything, it's possible that your management is not great. Maybe you didn't do a great job managing, maybe the manager above you is not great. You're still going to have to deal with different types of people, sure. Hopefully, bad project management kind of filters out over time, but I have seen that too. Wrong choice of module. We decided to go with um, a paid for library because we knew it was expensive and we could license it, when in reality, there's a better open source module out there that runs 10 times faster and is much easier to use. But it's open source, so bad. A single missing semicolon. Well, at least with a missing semicolon, you get a compilation error. It's not one of those like awful segmentation faults or stack dumps that you get. Yeah, so all good. Definitely. Definitely good. So here is a list of the top 10 risk items for software projects, and this is more or less pretty timeless. So, personnel shortfalls. We don't have enough people. We can't hire enough engineers. We don't have enough talent. Basically, we don't have the right set of people involved. So you all got this one, which is great. Budgets not managed, schedules not managed. Could be that it is unrealistic. And unrealistic can be driven by market forces, it can be driven by business decisions. It can be that you're a young, fresh engineer ready to prove everybody wrong. Yes, I can get this done in 1 week, and then it takes you 3 months. Again, I'm not trying to like say that's what's going to happen, but it is possible for people to be unrealistic with their expectations. Whether it's the person on the team driving it or the manager kind of overseeing the project, hopefully some voices of reason will come to light if that's the case. You also got this one too, so good job. Developing the wrong functions. We developed something wrong. Oops. All right, let's talk about these two. Wrong functions, wrong user interfaces, all driven by probably bad communication or misunderstood requirements. Right? You all go out and develop a beautiful website front end for, let's go back to that online store example where you were all definitely not implementing Home Depot or Lowe's website. Well, you all did it, and it's great, and you made it responsive and you made it beautiful. But I'm old school. I wanted it rigidly defined. I want it 960 pixels wide, and I am not supporting mobile devices because I'm a dinosaur, and I hate mobile in general. Mobile's fine. Got a phone. Insert Diablo 3 on phones joke. But basically, you misunderstood something, and I misunderstood what you were all doing. We end up with the wrong interface. Customer is unhappy. Gold plating. This is a fun one. So has anybody heard of this term in terms of, I guess, software or projects? So this is kind of an interesting example. If you're gold plating something in general, you're taking like a less valuable metal and covering it up with a gold covering, right, to make it look pretty. That's exactly what we're doing here. We have a poorly built project and we're going to dress it up to look absolutely beautiful and everybody thinks it works perfectly. But in reality, it doesn't. Yeah, absolutely. Mobile Diablo. That's what everybody wants. I am very excited for that Diablo 2 remaster, though. I will say that. So gold plating, let's dress up a horrible, badly functioning project with a beautiful GUI or, something that is going to make people think it is better than it really is. And in reality, we have all those risks just waiting to be discovered under the hood. Requirements changes continuously happening. So basically, customer keeps wanting something different. This is why if you're going the web development route or you're going the mobile development route, don't allow your customer to change the project 30 million times along the way. You end up with a bad product. All right, let's add the rest of these in. Shortfalls in externally performed or externally furnished things. So your contractors aren't doing what they say you should be doing, or what you say they should be doing. Modules that you have purchased fall short. Basically, things outside of your internal corporation are not doing what they say they should be doing. Can be something that you have to deal with. Right, you are an agile team, there's 3 of you, and you realize that you are all great at back-end development, right? You can set up a LAMP stack, you can set up a game server, but you need a little bit extra polish in terms of the graphics. So you go out to Fiverr and you say, hey, I need 500 enemy assets because we're going to be varied in our, enemy units or something like that. And you're going to get a range of qualities. You're going to get a range of people just not delivering on time. And basically things will fall short because of other teams, other entities. Maybe you get into the world where you have real-time responses needed. So you are in the embedded systems area, or you're doing graphics programming, and things have to be happening right at real time. I don't know I did that little snap because it looks really dumb on camera. But, maybe we have a real-time operating system where tasks have to be scheduled appropriately. And if things start kind of piling up or they're poorly programmed, we're going to start missing our real-time performance metrics. Things are going to slow down, or they're going to lag, or they're just going to stop working. Maybe Maybe your customer doesn't even understand what the thresholds of computer science are. Um, your term project for this year, implement quantum computing on real hardware. Because I read an article that quantum computing is the next big thing. And then you say, well, sure, there are Python libraries for quantum computing, but we don't actually have quantum hardware outside of what IBM simulates on a cluster for us. And I say, I don't care, make it happen. I'm the manager who's going to shake my finger at you and tell you to make the impossible occur. There are people like that out there, and they're typically the ones that don't really understand the technical side of things. And it's up to you to convince them to do that. So, that is all from this set of slides. Any questions from today at all? Because I think otherwise we can probably end a couple minutes early, because otherwise we're going to get into what we're doing next time, which is part 3, cost estimation and earned value analysis, which has this figure, also has this figure, and, ooh, this figure. But we'll save that until Wednesday. Questions at all? Term project questions at all? Anything class related, I suppose, since we have a couple minutes. Well, if there are no questions then, I suppose I can let you all go early. Because I sped through that material. Anyway, I hope you all have a wonderful Monday. I will see you all on Wednesday. You as well. Thank you. It's hypnotic. Need to set up a 24-hour live stream of just this. Watch the subscribers pour in.